Good afternoon, ladies and gentlemen. You may have been to a lot of presentations, and welcome to this one at the conclusion of what I hope has been a successful day for you. It's my pleasure to introduce Mike Richards, G4WNC, and got a simple topic, as you know, Raspberry Pi. Well, I've already got a question for you before you even get to the question, and that is, what on earth does it stand for? But you may well wish to touch upon that point. Mike's part of a well-known duo. You've probably seen him earlier in the day, helping us with photographs, which is an important part of protecting image of the event and of the RSGB, and of course, we all know Elaine, the RSGB Radcom editor. Do you know, I nearly said bulletin, took me back about 30 years there. Anyway, we're all going to listen to Mike talking about Raspberry Pi, so the floor is yours. Thank you very much.
Okay, thank you. Can you all hear me okay? Is that coming through? Oh, they've got some shakes of heads. Does it need to go up a little bit more? Oh, I've got a mic. It's okay. How's that? How's that sounding? Good show. Well done. Well, thanks for coming along. I know it's the end of the day, so it's a bit of a struggle, so I'll try and make this snappy. There'll be questions at the end, but if you want to ask as we go along, please feel free, just put your hand up and chip in. So, yeah, chip in, that's a good one, isn't it? So just quickly, let's summarise where we are with the Raspberry Pi. It was originally designed by a team at Cambridge to promote interest in university-grade computer science courses, because they'd seen over the years that the applications were just dwindling and dwindling, and they wanted to do something about it. And when they thought about it, what they realised was that in their youth, you had Commodores, you had BBC-Bs, there were lots of readily available computers that you could learn to program on. But we've now got to a point, well, until before the Raspberry Pi arrived, where everything was done for you. The kids are all on computers all the time, but all they're doing is playing games and surfing around the internet. They're not actually generating any new code. So the idea of the Raspberry Pi was to get that moving and give the kids a computer that they could actually learn on. So it had to be cheap, it had to be powerful, and that's what they set out to do. Now, when they launched it, immediately there was a strong interest from the maker community, which is like the do-it-yourself community, who suddenly recognized that this little computer was actually extremely useful in all sorts of other fields. And the net result is that now, the Raspberry Pi is the third most popular computer behind the PC and the Mac. In the last 5 years, they've sold 12.5 million of them, and it's still going there. The factory in Wales, the Sony factory that produces the things, is working flat out every month, producing the Zero and the Pi. So it's a really big success story all round. And if you look at what's happening in the kids, if you've got any kids or grandkids that are at school, are at the sort of age where they'd be doing this, you'll find that most schools are involved in the Raspberry Pi. They've got a separate organisation in the foundation looking entirely after the educational aspect. So it's become a huge project, and it's great for Britain for getting those computer scientists that we need for the future, which hopefully will spill into amateur radio as well, because there's all sorts of, I'll show you, amateur radio things you can do with the Raspberry Pi. So let's just quickly cover what it is now, because it's evolved through several iterations. So the Pi 3 is the current Pi that you should go and buy if you're going to buy one, okay, which is a quad-core 64-bit processor. It runs at 1.2 gigs. It's got a gig of RAM, dedicated full HD graphics processor on board. It uses a micro SD card instead of a hard drive for its operating system, which means you can just transform it into a completely different PC just by changing the micro SD card. So it's really flexible. It's got 40 general-purpose input-output pins on it, which can be configured to do all sorts of things, to control external devices or to communicate with external devices. And it's also got dedicated serial camera and display connectors on board. It's an amazing amount on board. And the Pi 3 brought with it onboard Wi-Fi and Bluetooth, which was a major thing to add in. It was quite a headache for the Raspberry Pi organisation to do it, because there's so much compliance testing to do when you want Wi-Fi and Bluetooth into a commercial product. It's got its own dedicated operating system, a branch of Linux. In the current distribution, you get the full Libre Office suite, which is just like your Microsoft Office suite, except it's free. It will open and edit all the standard Microsoft documents, and it's free. There's a full suite of programming tools on there, some of them that you'd normally have to pay for, but they're actually free if you put them on a Raspberry Pi. And the support for the Pi is incredible. If you get a problem with a Pi, if you go on Google, put that problem in, you can guarantee you'll find answers all over the net from all sorts of people. There's a dedicated forum on the Raspberry Pi site, but there's loads of other forums. There's a dedicated Raspberry Pi amateur radio forum. So the support is amazing. There's no other product that's got as much support as the Raspberry Pi has. How much does it cost? £32. Isn't that ridiculous for all that? £32, and that's how big it is. You know, it's all it's all on there. So there's a picture of it, so you can see what. So what we've got here, we've got 4 USB ports over here. That's an Ethernet port, which runs at gigabits. That's an audio port, which is a bit weak on. I'll cover that later. That's a full HDMI port. That's the power, micro USB. That's where the micro SD card goes. And these are all the pins you can program up. So you can see it's really well thought through and is packed with flexibility, effectively. As if that wasn't enough, they brought out the Pi Zero. Now, the Pi Zero is less powerful. It's got a 1 gigahertz ARM processor, but it's already 40% faster than the original Pi when it came out. It's got a decent amount of RAM. It's still got the same full HD graphics processor on it. It's got the 40-pin GPIO, but it's unpopulated this time, which means there isn't a socket in it, so it's just you can solder on there or put one in there. And it's absolutely tiny. It's that size. Okay. And the latest ones have got a serial camera socket on the side. £4.80, you know. It's crazy, isn't it? It's so crazy, when they brought it out, they gave it away free on the front of the Magpie magazine. And if you take up a subscription to the Magpie magazine, you get one for free anyway. Okay. So, and the other great thing about it, not only is it cheap and powerful, but it's made in Britain. Even better, you see. So we have got a manufacturing industry, and it can succeed. So another variation, which is the Pi Zero W. So what everyone said when the Pi Zero came out was brilliant, but we have to keep adding things to it to connect to the outside world. So okay, so we'll put Wi-Fi and Bluetooth on it. So it's now got the full Wi-Fi and Bluetooth on it, exactly the same chip, etc., as on the main Pi 3, but it's £9.60. So that's actually that one. It's £9.60. And if you look at it closely, I've got a picture here somewhere. If you look down here, there's a little triangle, and that's rather a clever little slot antenna for 2.4 gigs, which is the first time I've seen that on a PCB, but that little triangle there is a little slot antenna for 2.4 gigs, which was something of a revolution when it came out. The other great thing is the cases that they brought out with the Pi Zero. These are the official Raspberry Pi cases. Wonderful little neat things. And there's not a screw in it. The Pi clips in. It's all precision molded stuff. The Pi clips in, and these different lids come with it. So you can put a camera in there. So you put it together with a power supply, and you've got a camera unit, which you can use as a dash cam in the car. You can use it as a security camera in your shack, trail camera for nature stuff around the garden. Isn't that brilliant? It's really good. So that's the cases. So when you buy the official case for the Pi Zero, that's what you get with it. You get this little adapter here, which converts the Pi Zero to the standard Pi camera. And then you get this one, which has got the camera hole in it, this one, which has got the GPIO bit, and that one's just a closed-in one. And that's all just £6 for all that lot, which has got to be good value for money. So it's sort of the theme of the Raspberry Pi that they keep bringing out incredible products at a ridiculously cheap price. This year, there hasn't been any new hardware. They said that this year was going to be a software year. So I'm sort of expecting they're going to surprise us again next year with some bits of hardware, probably some improvements to the USB and network connectivity. But that's just me guessing. So the operating system we're using for the Raspberry Pi is Linux. And the way Linux works is there's a Linux kernel, which is, as the name suggests, is the core of the language. But in order to make a useful product that goes out to all, you have what are called distributions. So you add a graphic user interface, you add the Libre suite of programs onto it, etc. And you wrap that all into a package, and that's called a distribution. So there are lots of different distributions. You will have heard of probably Debian, Ubuntu, Linux Mint, etc. So the Raspberry Pi comes under Debian, and the name Raspbian, which you will have heard, you can see is a concoction of Debian and Raspberry Pi. So that's where the Raspbian word comes from. But you also heard it called Raspbian Jessie, Raspbian Wheezy. Well, they got humour. Each distribution is named after a character from the Toy Story. So Jessie is simply the name of the cowgirl in Toy Story. And the current one, which has recently come out, Stretch, which is the octopus from Toy Story. So that's where all the names come from. So what do you need to turn this into a useful computer that you can do things with? Well, the first thing you need is a keyboard and a mouse, and most people use, you can get combinations of a wireless keyboard and mouse, the little Wi-Fi plug-in. They work brilliantly. I put that one up there because that's one that I use. I've used the PEREX keyboards with it for a few years now, and they're very reliable, and they take a lot of abuse being carried around in my case, etc. On the network side, the best way to connect really is with Ethernet. It's simple because there's no configuration. It self-configures. As soon as you plug a Ethernet lead in, the Pi notices it, gets its IP address, and is in business. The Pi 3, of course, has got Wi-Fi, and that's really easy to configure on the graphic user interface of the latest operating system. It's a simple little panel at the top that you can click on and find your local Wi-Fi and connect up. It's very similar to what you do on your laptops and your PCs to get on the network. And for the display, you really want to use an HDMI monitor. Please don't use composite monitors with the Raspberry Pi, because it's a real spoil in the product, because it does full HD 1080p output, and it's designed to feed into an HDMI monitor. So any TV, your hotel TV, if you're in and you want to use it, will work. And that works absolutely brilliant, so please use that. Power, you can power it all sorts of different ways. It just wants 5 volts. If you're buying a plug-top supply, which most people do with it, initially, get a higher power one, not because the Pi needs it on its own, but as you add different things, you might want to add a disk drive, and it's as well to have that extra power available. So go for a 2 or 3 amp one. The other thing that works really well is these mobile phone power packs. I expect you've seen there. You can charge your mobile phone and various things. So it's a LiPo battery, and it's got USB plugs on it, and it outputs absolutely rock solid 5 volts. I've tested a whole load of these, and they sit at 5 volts within just a few millivolts, right to the point where they expire, just shut down. So they're ideal. Well, I mean, that one's I think it's about a 10 amp hour effectively. That will power a Pi for a couple of days quite happily. And the other way you can do it is use the little LiPo batteries that are about with one of these Buck power booster little regulators, which will knock it up to 5 volts. Another interesting way, because if you're running a camera or you're running a Raspberry Pi as a remote server for an SDR, you can combine communicating with the Pi with the power and use power over Ethernet. Now, you don't have to go for the full commercial option, because there's an easy way. So that's how you'd connect up normally. So you can just see there, that's all you need is the power supply, a monitor, keyboard and mouse, and Ethernet. And you can use that like a bog standard PC. You can go internet surfing, do your email, and all sorts. So if we look at power over the Ethernet, this is how it works. At the home end of the network, you have a connector that goes into your Ethernet port, and there's a socket sat there that you can put volts into, or 12 volts, or whatever you're sending up there. And at the other end, there's another splitter, which splits it back out, so you get a separate power supply and Ethernet. So that way, you can have one cable going up the garden or up the mast or whatever that will supply the power and also handle the connectivity. It's really easy to do. You can buy those, the splitters and adapters on Amazon for between £5 and £10 for a pair of them, so it's dead easy to do. And they've got standard coaxial power connectors on them as well. So the way it works is the 100 megabit Ethernet uses only 2 pairs, and standard Cat5 cable has got 4 pairs on it. So you've got 2 pairs not doing anything. So all you do is you bunch the other 2 pairs and use them to carry the supply. And if you bunch them, it's up to 1.2 amps you can carry through that, which is tons. So if you want to do it yourself, I've put in here the details. I don't need to go through it here, but that's the normal wiring that's used for PoE. These slides, by the way, will be on my website Monday morning, so you can download them all. And they're also going to be on the RSGB site. So save you making too many notes, because there's lots of URLs and all sorts later on in this. Why reverse them? What did I do? Oh, right. Sorry about that. These things happen. It's called learning. If you're putting 12 volts over these, please don't connect your shack power supply straight to a bit of Ethernet cable, because it won't half light up if you get a short anywhere along it. So put something at the end to limit the current through it. Headless operation. And by headless, I mean all you have is the Pi powered up and connected to a network, no keyboard or mouse on it, okay? But in order to set it up, you need to initially connect a keyboard and a display, because all the remote connectivity is enabled by default, okay? So you connect it up, and there are 2 tools that are really useful. A tool called Real VNC allows you to see the full graphic front end, the full desktop, remotely over the internet. So it's just like you've got the Pi running with its GUI on your computer wherever you are. And that's one of the things that you normally have to pay a license for, but on the Pi you get it for free. The other way is what's called SSH, and that gives you simple access to the command line for doing command line stuff. So yes, you could, yes.
And then you get the full graphics on the PC.
Yeah, it's the same sort of thing. I only said Real VNC because it's probably the simplest way to do it at the moment. So that's what a headless setup looks like. So if you want to use the Pi in the shack and you don't want to have another keyboard and monitor, you can just connect it up in the shack like that and then access it via Real VNC, and you can use it on your main computer. So one of the things people often get stuck with, many of these applications, you need to know what the IP address is of your Pi in order to use it. So there's a couple of easy ways to find the IP address. If you've got the graphic interface up, if you just hover over the 2 arrows at the top, which is where the Wi-Fi and the net connection is, it will tell you what the IP address is. Or you just open a terminal and type in hostname -i, and it will tell you the IP address. Now, when it comes to trying to fix an IP address, the way I prefer to do it these ways, the nicest way, is virtually all modern routers are able to pair up an IP address with a MAC address for the computer. So your Raspberry Pi has got a unique MAC address on the network. And so you can set the Pi to always give the same IP address to it. So that way you don't have to worry about setting up fixed IPs, etc. If you just tick the box that tells it to allocate the same IP address, it's the same as a fixed IP, but you don't have to worry about any clashes because the router handles that. So from that point, I say it's better than a static IP. So now, where I'm rushing a bit at the moment, I hope I'm not losing you. Now I'm going to look at some projects that you can do with the Pi that work and have been well proven and are a great way to make use of it. The Pi makes a great data modes terminal because all you need is the standard setup and a USB sound card. Because I mentioned earlier that the sound wasn't very good on the basic. It's not. There's no audio input, and the audio output is not terribly clever. The easiest way to fix it is just to plug in a USB sound card. They're really cheap. Ideally, you want a USB sound card with a short tail on it, because most USB sound cards are quite chubby things. And if you put them straight into the ports on the Raspberry Pi, you'll find you block up the ports, so you can't use the other ones. So the best one to have is got a short tail. You can get these from any of the Pi suppliers, but one that I've tested and used a lot from Amazon, it's one that Ugreen do. It's called an audio adapter, and it's under a tenner. It's really cheap, and I've used it on all the programs I'm talking about here, and it works fine. Also know that Signal Link works fine, and we'll go straight into Signal Link USB. For transmit-receive switching, to be honest, the simplest way for most data modes is just to rely on Vox. Because unless you've got a mode which is sensitive to changeover switching, Vox is fine. But if you do want to do tighter switching, then you can get a USB serial adapter to do that. And one thing that's really useful if you're using it as a data modes terminal is to put a little potentiometer in the audio output to adjust the level, because the drive level into the transmitter is critical, and it probably varies from band to band, so you're going to want to tweak it slightly. So it's really good just to have a simple pot in the transmit line. So what programs do we use? Well, for general data modes, FLDigi is extremely well proven on the Raspberry Pi. It's got a wide range of data modes. It's got login built in. It's really easy to use. And all the modes in it, including the multi-band, the whole band decoding, simultaneous decoding, all works on the Raspberry Pi, on the 3. However, if you install it from the Raspberry Pi repository, it's still a very old one on there. So, which is a bit of a nuisance. I don't know why we can't get that up to date. But there's an easy way. I can't remember the guy's name, but his website is IndieHams. If you Google IndieHams, go to him. He's written a script which you just run on your Raspberry Pi. It downloads the latest FLDigi, which is 4.10 at the moment, which has only just come out. But it's up there, it's up to date. It will install all of that for you. It does it all, produces a desktop icon, and it also installs hamlib, so you've got control of your rig as well. So that's a really good way to get FLDigi, quick and easy. Although you have to start it from the command line, you don't have to do any command line stuff other than start it, and it does the rest. And it talks you through what it's doing as it progresses as well. So it doesn't just suddenly stop and say it didn't work, which sometimes happens, but not with this. So the other one that's good is QSSTV. This is a program I've tested quite a lot, which is a general purpose SSTV program if you're interested in SSTV. It's very, again, uses just the USB card. It's very easy to use. It does need to be compiled on the Pi, but it's actually very easy, and the instructions on the website are very clear and straightforward. Okay. And the other one, which is very topical at the moment, because as you probably all know, FT8 has gone a bit ape on the HF bands. Everyone's using FT8, which is part of the WS-JTX suite of weak signal modes. So they're now providing a Pi binary of the latest release, which is RC2. And that's the one with the latest FT8 fixes in it, so that's the one you should be using. That's available from their website, and they've got very good instructions on how to install it. So that gets you working there. If you head that, just type in WS-JTX on Google and you'll find it. And this is fully functional on the Pi, but all the modes only work with a Pi 3. It will run on a Pi 2, but you won't get all the modes working properly, so I should stick with the Pi 3. Now I do a ready programmed, I'm not really here to sell stuff, but I do a ready programmed micro SD card, which has got all these modes on it, all tested and working, complete with printed instructions on how to set it up and everything else. So if you want one of those, just go to my website. So that's a data modes terminal. So how about Packet and APRS? So it's really good for that as well, unsurprisingly. So you don't need to bother with a traditional TNC. When Packet started, we were all buying TNCs from all over the place to handle the link, basically. The protocol of the link was handled in hardware. You don't need to do that anymore because there's some software called Direwolf which really works well and turns the Pi into a very useful TNC. It's available free. Again, it uses your ordinary sound card. You can use Vox for transmit and receive. It's to be compiled on the Pi, but it really is a simple process, and the instructions are very clear on that site. So on that site, you can download all the files you need, and the instructions are there. So don't forget, you'll get these slides. You can download these slides, and you'll have all the links. So what we can also do, we can do some APRS, because the Direwolf software opens up ports for APRS connections, etc. And a client for APRS that works extremely well on the Pi is called YAAC. It's yet another APRS client. It's got a sense of humor. It works very well on the Pi. It's a Java application, so it's transportable across different PCs as well, so you can run the same application on your PC. In fact, you can leave the Pi working as a TNC with Direwolf on it and run YAAC on your main PC and link it through your own network. It's dead easy to do. So you can get it there. It's another free download, and it works a treat. I've had it set up with, I've got a little beer fang 37-pound 2-meter 77s with a Raspberry Pi, and it works beautifully as a little iGate. Absolutely no trouble at all. Dead cheap. I just said that, so I don't need to do that. So I've published instructions on how to do this on my website. So I've done a little tutorial as to how to install Direwolf and set it up as an APRS station on my web, so you can find that easily. I only did that last week, so it's at the top of my blog, and you'll see it on there. You could also, if you want to make it into a tracker, an APRS tracker, all you've got to do is add a GPS input. So you can have a USB plug-in GPS unit, or you can put one of the GPS hats you can get that fits specifically on the Raspberry Pi, and then you've got a very neat little APRS tracker. So what we got next, this is where it gets really interesting, this bit. So SDR server. We've been doing this for a while with the RTL SDR software. So what I mean by an SDR server is that the Raspberry Pi is set up with, say, an RTL dongle as a SDR receiver, and it's up the mast somewhere or somewhere else, and you have a network cable coming back to the shack, which carries the RF effectively, or the IQ signals from that receiver, so you can operate it remotely, so that you don't worry about losses in the coax, because there's only a short bit, and you get this away from all the noise of the house, etc. You've still got to protect it from the noise of this thing, of course, but that's a bit easier perhaps than protecting it against the noise from everything. So that's really easy to do. And as I say, the Cat5 Ethernet cable is used to carry the data. You can also, using that power over Ethernet I mentioned earlier, you can also use it to power the thing as well. So wherever you put the Pi, all you've got is one cable going to it, and the Ethernet cable is dirt cheap these days. And a Pi 3 can handle up to 4 instances of this. So you can effectively have 4 different SDR receivers, admittedly at lower bandwidth. Okay, so if you run 1, you can run about 2 megabits bandwidth, but if you run 4, you're coming down to probably half a meg bandwidth. But if you're using it to monitor a number of amateur bands on a contest or something like that, that's still plenty. There's full instructions there, which is on my website. I've done a blog with full instructions. People have been using it for years, so it's gradually been refined, so I know it works. And I also do cards that are ready programmed if you want. So this is what it looks like. Very simple, and then you put the power supply in at this end. So all you've got is a single cable going out to the Raspberry Pi and the RTL dongle mounted remotely. Now, where it gets interesting is something new that's just come out. Well, it's been developing over the last few months called Spy Server. I've been mentioning it in my columns. And we've got Youssef and Ian over there as staff from the AirSpy team who've been developing this as well as the AirSpy receivers. And so this has been designed for AirSpy, but it does also handle RTL dongles. So one of the things that's about this is it provides a low bandwidth mode for internet sharing. So the normal problem, if you use the previous SDR server, it's sending IQ data down at 2 megabits. Now, if you try and get that over a Wi-Fi link, you'll struggle. Okay, and if you try and get it over an internet link, you'll struggle even more. It just won't happen. So the problem is, how can you use an SDR remotely and get all the facilities of being able to see a wide bandwidth and click on and resolve any one of those you like? How can you do it? And so that's what they've mastered here. And the other thing they've added, which the previous server didn't do, is you can have multiple connections. Okay, the SDR server only had one connection, that was it, no one else could get in. When you do have a multiple connection, of course it freezes the tuning, because otherwise they'll all be fighting for the tuning control. Okay. But that means whatever bandwidth you've got, so say you've got 2.5 megs of bandwidth coming down, you can have multiple people and they can tune anywhere within that 2 megs of bandwidth. So it's still very useful. So let's look at what the problem is and how it works. So this is where we start. If we use the AirSpy as an example, which is what it's been designed for specifically. So normally with the AirSpy, you can run with 10 megasamples per second as the download rate, or 2.5, okay? And I'll use 2.5, all the Pi can tolerate at the moment as an example. So if you run at 2.5 megabits, full IQ, the data rate over the Ethernet is 80 megabits a second. So you can see why that would be a problem on a Wi-Fi link, or if you're going through the wider internet, that really isn't going to work. So, ingenious solution. So you start off with the 2.5 megabits, but you send it into a Raspberry Pi. Now, the first thing they do is look at the FFT. So the fast Fourier transform is part of the mass that produces the spectrum display we all know and love with SDR receivers. And the spectrum display enables us to see all the activity in the band and allows us to click tune anywhere in the band. So, but in order to see that, you don't really need to have the whole 2.5 megs sent to the distant end, because all you want is actually the video frames of that spectrum. So that's what they do, is you get that spectrum and you generate the video frames for that display in the Raspberry Pi and then just send the video frames back to the over the Ethernet. So that's good. On the Raspberry Pi, the default rate is 20 frames a second if you just get the software as it is. But on the Raspberry Pi, it struggles a bit, and 10 frames a second, it runs quite happily. So what do we do about the rest? So what happens here is you downsample the 2.5 megs coming in into a much lower value. Now, I think it downsamples to about 50 kilosamples per second, somewhere of that sort of region for narrowband signals. And in the very latest version, you have this option to alter the quantization between 8, 16, and 24 bits. And that overall gives you a very much lower rate over the internet. So we're now talking about 300 kilobits per second. Now that's doable. That will go over the internet relatively easily. And with those adjustments there, if you've got a really good link, you can take more resolution, or you can drop it down if you've got a poor link. Now I think this is really important because it changes what we can do. So now you can put, so if you live in a lousy location but your auntie lives at the top of a hill, okay, you can perhaps persuade her to get a Wellbrook antenna up there and an AirSpy, connect it into her internet. It's all very small, and then you can have it routed down to your shack, and so you can have a high quality receiver from a good location, not at home. So everyone will be looking for aunties that live in high places now, I think. But it's just a really useful extension that we haven't had.
Would that work over Wi-Fi network?
Yeah, it should do, yeah. Yeah, I've used Wi-Fi, yeah, it will. Yeah, no, it's really good. So what you get at the end of it is, with the Pi, you get 2 megs of bandwidth, effectively, to tune over. So you get the full FFT display for 2 megs of bandwidth. You can click tune on anywhere on there, using the standard SDR Sharp software or even Simon Brown's SDR console. You've got a low-rate IQ feed, which is providing the IF, if you like, for demodulation in the computer. So it looks and feels exactly as though the AirSpy was connected directly to your computer, but it only uses a very low bandwidth over the link between the two. So that immediately gives you enormous flexibility to start doing remote operating with a really good quality receiver. If you want to go faster, there's been a number of lookalike boards come out on the Raspberry Pi, small computers, small single-board computers. I can't get the top off. But that, which looks remarkably like a Raspberry Pi except for the heatsink, is a unit produced by Asus, who are a fairly big computer manufacturer, called the Tinker Board, which is all the same sockets in the same places as a Raspberry Pi, is compatible in most places, except it's more powerful, and it's also got gigabit Ethernet and fast USB 2. Now, the problem with all these boards, they're more expensive. So this is about 50 quid. And the other thing you notice is because it's more powerful, it gets hot. It gets very hot. So it needs that heat sink. If you try and enclose it, you need a fan on it as well.
Is it Intel or ARM-based?
It's ARM-based, yeah.
So it's
Yeah. But it's not Raspbian. You can't put the Raspbian operating system. You need a different operating system on it. But if you want to do 10 megs, you can do it with one of these. And there's several others, but they all are more expensive, significantly more expensive than the Pi in most of these, and they also get a lot hotter because of the processing that they're doing. So I've covered that. The quantization adjustment lets you adjust the link quality. Now, it also is designed to work with the new AirSpy HF. I don't know whether any of you have heard about this. This is the next generation of AirSpy receivers, which is going to be stunningly good and should be available reasonably soon. Now, that would be absolutely ideal to put that in a remote location and route it back to your house through the SPI server. So that will be quite a powerful combination. So on the same sort of theme, one of the things that people have been asking for ages with the Raspberry Pi is, oh, can it be my SDR receiver as well? And it's sort of always been a bit of a step too far. It's pushing it, and it's still straining it a bit to get it to do this. But Alex, who's just been talking in another room, in fact, I came from his presentation to nip in here. I had to miss the bit to do this. So Alex has been doing an awful lot of work with his GQRX software. So this is still experimental, and he's doing another layer at the moment where he's starting again, effectively. But it supports multiple SDR receivers on the Raspberry Pi. So the list currently is that. So you've got the RTL SDR, the AirSpy, AirSpy Mint, FunCube Pro, and the RF space. Now, there's some limitations against all those as to what bandwidth they'll use, etc. And if you go to his website, got full instructions on how to download it, how to install it, and what the maximum settings are for each of those receivers. So it does give you the opportunity to get an SDR receiver working on the Raspberry Pi. What you won't get, certainly at the moment, is to do that and then run the data mode software on top of it on the Raspberry Pi, because that's asking too much again. Because one of the problems with the Pi is the network ports and the USB ports, because they all share the same chip and the same bit of bandwidth. So there's always a bottleneck there. So when you're plugging in a high-speed SDR receiver and trying to send it out, you're all going around the same chip. So that's part of the reason for the bottleneck there. So that's the website where you can get all the information on GQRX. It's well worth a play if you want to try using a Raspberry Pi as an SDR rig. You could, they're so cheap, you could buy two, couldn't you? You could have one with your data modes terminal on and the other one with the SDR receiver on if you want. So because it's asking a lot of the Pi, it's really, you should really only do it with a Pi 3. Some of it will work on a Pi 2, but you'll probably be struggling and a bit disappointed. So stick with a Pi 3, I would. Is someone doing timekeeping? I'm not sure how I'm doing.
4 minutes.
All right, that's good. Okay. One final quick, easy one is a security camera for the shack or a trail cam for spotting hedgehogs in the garden, etc. This is really easy to do. There's some software called Motion OS, and it's a self-contained operating system, and it links with the Motion app, which is a Linux app for movement detection. One of the great things about it is it doesn't use a PIR to detect movement. It actually analyzes the image on a screen to detect movement. It's really simple to use. It's got a nice web interface, and you can make a trail cam or that really easy, because you can literally put it all in there, and you've got just with this bit of software, and you've got a camera that you can use as a dash cam, whatever, and it will save either to the SD card on the Raspberry Pi, or it will send it over the network to a server in the house or cloud storage, wherever you like. It's really well done. It's very easy to use. If you search out Motion iOS on Google, you'll find it. And I also do a card that's got it as well, just happened to. Yeah, okay, you've got that. And here's some little things that are useful. So this is a thing called Zero View from Pi Hut, which is one of the Pi suppliers. And it's a little printed circuit board that takes a camera on it. So it's only £7. So if you want to do a security camera in the shack, you just stick it on the window with a lead down to the Pi camera, Pi itself, and it's dead easy to use. And the other one they've just brought out is this one called a Zero Cam. So it's an infrared camera with 2 infrared lights, and you can have it with either standard view or wide angle. And it's £25, which is about the same price as the Pi camera on its own. So it's really good value. So if you're setting up one of these and you want an IR light to look after the shack or the house or whatever, it's a really good way to go. So let's just summarize that rather quick run through the life of Pi. And to explain why it's called a Raspberry Pi, there isn't a lot of logic in it, other than everything's called by a fruit these days in the computing world. So you've had BlackBerry phones, you've had apricots and all sorts, so Raspberry is just in amongst there. So you've seen a few of the applications that are pertinent to amateur radio that are dead easy to run on a Raspberry Pi. I can help you if you're stuck. And it's also an excellent platform to learn programming. So a whole load of languages are on there for you to start. There's loads of language support. There's online tutorials that are free for all the main languages you might want to be interested in. And it's a really good tool for it. If nothing else, it makes a great media center at home to put all your films on and run your TV. Elaine loves it at home. She's got all her films in just a click of a button. As I said, I've got preloaded micro SD cards for most of the applications that I mentioned here if you want them. When I sell these, I only sell them for £9.50. You get an 8 gigabyte card, you get printed instructions, and you get one-to-one support if you get stuck. So can't do better than that, I'm afraid. Hopefully I could have a SPI server and a packet radio card sometime this month, but I haven't finished on that yet. And if you want to find out more, that's my addresses and QR code, etc. Any questions, folks? Stunned or asleep? I'm not sure.
Couple of quick questions. Any offers?
No. It's the end of the day.
Well, Mike, actually, I have to say, I thought that was masterful, actually. I mean, you just covered so much ground. Ah, we have a question.
Ah, well done.
Do you have any experience, recommendations, whatever, of screens actually manufactured and sold specifically for the Pi?
Well, the official Pi touchscreen is particularly good because it uses a very high-quality display. Okay, they're very particular about the type of display that they used for that. And they did choose a really good one that's going to have support over a long time. There's a lot out there, a lot of people advertising screens for the Pi, and some of them are a bit rubbishy, to be honest. And what you find with them is they've got a very narrow viewing angle. So if you go off of directly on, you'll find the colours go or the contrast goes or whatever. If you look at the Raspberry Pi one, it's got a really wide viewing angle, which is a good sign of a good quality display. So if you want a small 7-inch one, then go for that. But if you want a bigger monitor, really just any HDMI monitor you like, really. You get what you pay for generally. Yeah, not any specifics after that. Okay.
Time for one more.
I have one of the early ones of those, and the front panels come unglued. Have you got any recommendations? How
Oh, I haven't heard that. I haven't heard that. Google it. No, I haven't come across that one. I must admit, sorry.
Okay, just one more, the last one. Yes.
How much what, sorry? The Pi touchscreen. Oh, well. I think they're about 60 quid, I think. I'm guessing now.
Is that like the one that's downstairs on the side of Martin Lynch? There's a little one.
Oh, it may well be, yeah.
Pi in the back.
Yeah.
Okay.
They're very nice touchscreens. They're really good quality and robust too. And they link straight into the screen plug on the back of the Pi as well, so it leaves all the ports free. Some of the other makes that you buy take up loads of that. They take out all the GPIO pins for a start and all sorts of stuff like that. Whereas the Pi one keeps everything still available.
Mike, thanks very much indeed. That was a great
Pleasure.
presentation, and there are lots of kind of generous links to how you find other things out, which I know people do appreciate. So very many thanks indeed, Mike.
That's right,
Thanks a lot.
pleasure. Thank you.